my question was explain why fluorescence is a problem in normal Raman spectroscopy. Give 2 examples of how the fluorescence interference in Raman spectroscopy is minimized or eliminated. I have some nice pictures on my slides, which did not post, I do apologize, so I'm going to do my best to draw some examples on the board.
Would it help to use the textbook?
Oh, yes.
Tab up here at the top right, all the way to the top. You can pick that arrow by Raman spectroscopy, the right arrow, so the table of contents, down 1, there you go. That'll open up more detail in case you need to jump into the section to look at that. More treatment. And if that's not helpful, go ahead and draw on the board, dude. I thought it might be a good thing. I guess it depends on how familiar you are with the textbook.
Figure 4.67. I'm going to draw it.
You're so close.
Alright, so fluorescence. What is fluorescence? And why does it occur? So fluorescence occurs when the virtual states populated by the excitation overlap, excited by electronic states in a molecule. So during Raman spectroscopy, I'm going to draw 2 graphs here. 2 spectra, should I say. Does everyone see the board here? So we've got an FT Raman spectra as well as a 785 nanometer dispersive Raman. Am I saying that correctly? Raman or is it Raman?
Raman.
Okay, so spectra B, as you can see here on the graph, when fluorescence is present, this is what it's going to look like. We're going to have, it's going to be very hard to see those peaks. The 2 different ways to reduce fluorescence, one, depending on the software that you're using, you can actually cut out the signal to noise and do that mathematically. But the issue with that is it actually affects it's actually affecting your peaks. So the fluorescence itself is going to affect the peaks that you're getting. So you want to try to reduce that fluorescence as much as you can so you're actually getting accurate numbers, precise numbers.
I have things to say, but I will hold off.
Okay. 2 of the ways, like I mentioned, one of the ways is to actually use the software mathematically, try to cut out your the noise in your spectra. The second way is the type of spectroscopy that you're going to use. So the FT Raman, this is an example here of the same scan, just using the FT Raman versus the 785 nanometer. And what this does is they use a laser. So the FT Raman is a better choice for samples because the fluorescence, pretty much what the laser does is the laser is low energy and it doesn't populate the virtual state that overlaps the excited electronic state. So kind of like I mentioned, so fluorescence itself is when the virtual states are populated by the excitations. Does that make sense? I'm not making any sense here.
Roll on, brother.
Okay, roll on.
Questions at the end.
So the fluorescence photon itself is a lower energy than the excitation radiation. So at lower wavelengths, it's going to interfere with the scattering lines, and that's what you see here. So the idea is to use the laser to bring it to even lower energy, so that way you're actually able to see the peaks and prevent fluorescence from occurring. Do you have questions? Am I confusing? Questions?
So I guess it was more of your choice of which type of instrument you use, right?
Correct, and also,
If you can't control the fluorescence from skewing your data.
yeah, depending on the analyte that you're using as well. So I think it has to do with the size of the analyte that the different types of Raman spectroscopy that you're using. So in this case, they were doing crack cocaine. And this is obviously isn't a specific picture, this is just kind of like an example.
What was the question you had? That you had? What was the question you had?
It was, what's the issue with fluorescence and Raman spectroscopy? How does that create problems for Raman?
And it prevents you from seeing the spectra. And there was another, I had it in my slide, it wasn't in the book, but I want to say it was SPERS, which is also another laser that they use to reduce fluorescence. Any other questions? Yeah. Come at me, Dr. Flowers.
Good to get in the chat there.
Oh,
Whoops.
is it in there?
I have the book right here.
Okay, great.
I can read it.
You step over there and find it, and I'm gonna step up here and get this book back open. Then we're a little past the halfway mark, guys. We're gonna take a 5-minute break. You can take your book with you.
Oh,
Thank you, sir.
thank you.
What the heck? Whenever you find it, read it out to us.